Welcome back to my third video. This is going to be on energy consumption for a three-bedroom house, and I'm just I just what I'm interested in is how much wattage basically one house would make. So this is an Excel file. I've already configured the formulas here for where you see zeros, but I'm just gonna run you through what I've done. So I've configured the description here as to what am I looking at. Different households, they have different things that they have, but for a normal household you would usually have a geyser, a stove, a TV, a fridge, washing machine, other machinery such as like pressure cookers and stuff like that, and you'll have air cons and you'll have microwaves, or a microwave basically. So that's it about the description. You can add other things, but I feel like this is fair for a normal three-bedroom house. The quantity here is just to specify, for example, how many geysers are there and how many stoves are there. Depends on um, um, what the client wants, but since we are looking at just normal household, we are just gonna take different quantities as possible. And then the wattages, this we're just gonna take the basic wattages for different for normal household. We are not gonna go for industrial or commercial. We're just gonna use the residential plan. And then the total wattage is the formula here. You can see it's just the quantity of the amount of things that are in that house times the wattage, which gives you the total wattage. And the breaker size, this is just the wattage for one divided by the 230, because we are in Namibia and we know that we have a standard of 230 volts connected to a household or associated with the household based on the Namibian Statistics Institute. So we're gonna start off with the geyser system. So a normal household will have one geyser system. So we are just gonna say we have got one geyser system. It will also have one stove, and it will have let's say give or take, for this household we're just gonna go with one television set in the living room, and we're gonna have two fridges, basically one deep freeze and one normal fridge. For some people we are gonna say one washing machine. We're gonna go for other machinery such as vacuum cleaners and pressure cookers. We're just gonna say for example this are like four of them in a normal household. And then we are gonna go for air cons. For air cons we're gonna have one in the living room. We're gonna have one in all three of the rooms. So we are gonna go with four of them in our normal household. And then for a normal household, you would have one microwave. Bear in mind, we did not consider the lightings and the sockets, because usually sockets are connected to are supplied basically from things such as um, supplied sockets. Usually use them if, for example, you had to connect a TV, you would connect it to a socket, so we can omit that. And then lighting, they don't really take up much amp, so they are put on a normal 15 amp or 10 amp breaker, depending on how many lights there are. But we are just gonna consider for this example the major components. So for a normal household, geyser would be ranging between a 3000 watts, and then a stove would also be in the region of 2500 watts. And then a normal TV would have 500 watt, for example. A normal fridge would also have 1000 volts, I mean watts, sorry. A washing machine will have a 500 watt. Other machines, we can look at pressure cookers and stuff like that. They'll usually have a 200 watt, and because they are four, it will do the wattage calculation already. And for normal ACs, they would have a 2500 wattage, and for a normal microwave can have a 300 watt usage. So as you can see, the total wattages for the geyser, because it's only one, it remains 3000. For a stove, it remains at 2500 because it's only one stove. For a television set is 500 watts. For a fridge is going to be 2000 watts. And then for a washing machine, it's going to be 500 watts if they have one washing machine. And for other machines such as electrical stoves, because we are taking them to be four, they would have a total wattage of 800. And aircons, since there are four, they would have a total wattage of 10,000. And for microwaves, they would go for one, which will have a total wattage of 300. So what you would get to see is that on that normal three-bedroom house energy consumption, you are looking at the 19.6 kilowatt system that you are designing for that particular client. And you know the basic formula of power is equal to voltage divided by the current. Now you would want the specific current that you would want to supply to that particular house. So you would take the total wattage, which is 19,600, and you're gonna divide it with the standard voltage, which is 230 volts, and you're gonna get yourself a 85.2 watt, not watt but amp breaker, give or take, for that particular kiosk that you're gonna set up in there. So the breaker size that you can see here is just the breaker size that you're gonna design, that you're gonna incorporate when you do your single line diagrams. And bear in mind, they should always be rounded up because you don't wanna under design a client's house, and you also don't wanna over design a client's house. So you just up it a bit, but not way too much, in a case whereby that fault will not be detected by a circuit breaker. So for a geyser, if you can see that the geyser is a 13 amp breaker size that's required there, and we don't supply 13 amp breaker sizes, we only have them as 10 amps or 15 amp, you'd want to place a 15 amp breaker for that particular geyser. Same applies to the stove. Since we don't have an 11 amp breaker, you just want to put it on a 15 amp breaker. And for a normal television, you would put it on a 10 amp breaker, due to the fact that we start from 10 amps going up, and so forth and so forth. So that's the basic thing about energy consumptions for particular houses. Thank you very much.